so I'll probably go through and change it all again. But it's an ongoing thing. It's not something like I want to make into a product. I'll open source most of it, for sure, so other people can learn from it. But I don't want it to be a product because it is like a constantly evolving thing that I just do for fun. Yeah. Other questions? Guys, I have so much knowledge to drop on you. So much. You're not taking advantage of it. I know if Robin was here, he'd be yelling at me since we did last summer.
Yeah. Yeah.
Yeah, you tell him, Dave.
Yeah. I'm not good at that.
It's really Robin's forte. Yeah.
Wait, what's that thing you said that slowly turns the lights on and leaves off?
That's a function of Jarvis. It's an alarm clock functionality built into it. So I basically have the system set up with a bunch of endpoints, inputs and outputs, that I can combine together with macros that I define. So I have an alarm clock macro where I say at nighttime, whenever I'm ready to go to bed, I say, hey, I'm going to bed, wake me up at 8 tomorrow. And so then it turns everything off. And then at 8 a.m. the next morning, because it already has control of all these systems, it starts bringing up the music, really super quiet, and it brings up the lights over the course of like a minute or two, so it doesn't like blind me when the lights turn on. And then it opens the shades, and then it plays me the daily news. Yeah, that's it. It's just the news is it connects to NPR and downloads the latest podcast. The lights are a combination of Philips Hue and Z-Wave wall switches. The shades are that contraption that I showed earlier with the motor pulling them apart. And then the voice system is powered by Google, a technically not public API from Google for doing text-to-speech that you can use by translating from English to English and submitting a query to Google Translate, which is what I use, and it works really well. And what else? And then the music, it plugs into my Google Play Music account and just pulls stuff from it. Yeah, that's it. Yeah.
What was it like making the decision to leave Google for Shaper?
That's a great question. What was my decision like for leaving Google for Shaper? Yeah, I loved working at Google. Google's a phenomenal company. Smartest people I've ever worked with. Also, the most severe imposter syndrome I've ever had, which, if you're not familiar with imposter syndrome, is the sense that like you just don't deserve to be where you are. And everyone suffers from that at Google. It took me a while to realize it while I was at Google that it's normal to suffer from that. But you get there and you're like, oh my God, they hired me by accident. I should not be here. But I got over that, and no, Google was great. I learned a tremendous amount about manufacturing, about how to work with different people. I learned a lot technically too. The decision to leave was a complicated one for me. I spent a couple years working on a product that I really enjoyed, and when I left, I had started working on a different product that is not released right now. I don't know if they will release it or not, so I can't talk about it. But I was working on a different hardware product for Google, and I just wasn't as excited about it as I was about the initial things that excited me about Glass, like the healthcare aspects of it and the ability to use it to help people in ways where we couldn't use traditional computing devices. And so I really enjoyed working on that. And so then I started working on something else which was like interesting, but from a technical perspective, from an electrical perspective, was very similar. So I felt like I was doing a lot of stuff over again, and I wasn't learning as much. So I grappled for a while with going to a different team at Google or with leaving Google. And I had opportunities to go work on robotics at Google, which I'm glad I didn't, because that whole team was a disaster. As any of you would have seen, like Google sold off a lot of that part of the company a few weeks ago. I had the opportunity to work on a bunch of other X projects like Loon, which is like the floating internet hotspot thing, and the self-driving car. And I had done some small amounts of work with those teams in the past, and they were interesting. But part of it for me was I was super excited about what Shaper was doing. I know that at some point, I was employee number 7 at Shaper, but at some point I want to be employee number 1, like a founder of some hardware startup at some point in the future. And I wanted to get the experience of doing that, and I knew the team at Shaper and was super enamored with them, and was super enamored with the product after trying it out. And another part of it for me was I live in San Francisco, and Google's in Mountain View, and 2.5 years of doing that commute was like the worst thing. And I really just wanted to work in San Francisco. And so I may have stayed at Google if Google did any hardware work in the city, but they don't. It's all in at the Mountain View headquarters. So that was how I made my decision. I have not looked back. I really enjoy the time I spent at Shaper. If the right situation arose, I can see myself at Google again in the future, but not in the near future. Yeah.
How did you decide what field of engineering you wanted to do?
Great question. How did I decide what field of engineering? Yeah, so when I first went to college, I actually thought I would do mechanical engineering. So I was really into robotics, and robotics is kind of like a combination of computer science and electrical engineering and mechanical engineering. And I liked building things with my hands. And so a few things helped me decide. First is I took an intro mechanical engineering class and really didn't enjoy it. I took an intro electrical class and really did enjoy it. I talked to a bunch of professors. I worked in a lab the whole time that I was there, the Creative Machines lab, which is where I did a bunch of the robotics stuff I showed. And that lab was a robotics lab that kind of was an amalgamation of multiple different disciplines. And it was technically in the mechanical engineering department, but I talked to the professor who was in charge of it, and he's a mechanical engineering professor, but also teaches in the computer science department, teaches AI, so it's mostly like machine learning robotics lab. And I was looking at the robotics, and I was just most fascinated by the electronics aspect of it. And so I kind of tried all of it. And that's the nice thing about certainly any engineering school that I know of. You apply to be an engineer, not to be a particular type of engineer, and you have the opportunity to try the different things out. And then you decide what you want to focus on. And for me, it was electronics. But one of those pieces of unsolicited advice that I had in my slide deck was, as I call, being a jack of all trades but a master of one. And so that's the idea of picking one thing to be really good at, but also exposing yourself heavily to other things, not necessarily being an expert at them, not even necessarily being able to speak authoritatively about them, but being able to uphold an intelligent conversation or debate about those other topics, or be able to do them when you need to. And that's how I view my relationship right now with computer science and mechanical engineering. I do both of those things in my day job. They're completely inseparable when you're working on any kind of robotic product. Unless you're doing theoretical stuff, no one is just an electrical engineer, especially at a startup. I spend plenty of my time doing mechanical stuff, plenty of my time writing software, and I love doing those things too. But I made sure I exposed myself to all of them in college, and I'm very happy I did it that way. Other questions? Yeah.
Could you explain more in detail the mechanical scene that you talked about?
Yeah, the prosthetic hand. Yeah, that was so that's my oldest example that I can think of me doing what I would consider legitimate robotics work. So that was in high school, so 10 years ago, and that was I was really interested in robotics at the time. This was long before I knew that I wanted to be an electrical engineer. I was actually still most interested in the mechanical side of it. But I was also really interested in biomedical engineering and human body interfaces and things like that, and I still am, and I could tell you about many more projects where I've connected various things to my head and arms and all kinds of things like that. But in that particular example, I wanted to start learning about robotics, and I felt that was a cool way to do it because I felt like I could really help people with the research. So my thesis in that research, or what I proved in that research, was at the time the primary method for controlling prosthetic limbs for amputees, mostly for below elbow amputees, was using something called myoelectrodes. So myoelectrodes, you either implant or put them on the surface of your skin, usually implant if you want a really good signal, and because the signal is usually weak for amputees. And basically, like when you flex any of your muscles, and if you move your hand right now, you'll see this, all the movements in your hand are controlled by muscles in your forearm. So there's electrical impulses that come from your brain, go to the muscles in your forearm, tell those muscles to move, and that's what moves your fingers and allows you to do different things with your hand and your wrist. So the predominant way of doing things was to not try to interpret what the muscles were doing, but to intercept the electrical signals that were going to the muscles to understand which muscles are being triggered and to use that to control the hand. So the idea was, if my hand gets cut off, let's say, I sincerely hope it doesn't, but let's say it gets cut off, most of the muscles, depending on how they do the amputation in your arm, still function. You can still control them with those parts of your brain. So if you think about making a fist, you can still control those muscles that do that. So if you put an electrode on them, you can detect the electrical signals, and you can then interpret those signals with a microcontroller and use it to control some actuator that moves an artificial limb. The problem with that is if you move your hand around, there's a lot of different muscles in your forearm, and they all control different aspects of how your hand moves. Some control how your wrist moves back and forward, side to side, fist open and closed. These muscles are all right next to each other, and these are very low amplitude signals. Again, like instrumentation amplifiers, that's what they use with these myoelectrodes to amplify the signal. And you get a lot of crosstalk. So that's picking up electrical signals from neighboring muscles that aren't the ones that you're intending to listen to. And so you would get misfires, basically, where your prosthesis doesn't do what you expect it to. So there's a few ways to deal with that. Some ways are improved signal processing. At the time, the kind of state-of-the-art of that was already quite good and still wasn't good enough. So what I was working on was augmenting myoelectrode control with force sensor control. So it was, in addition to implanted electrodes, you put a cast over your arm with sensors that are sensitive enough to pick up the physical movements in your arm that are caused by muscles bulging, and to use that as an indicator to improve upon the crosstalk issues. So if you can detect both the electrical signal and you can confirm with the mechanical signal that muscle is the one that's moving, you can control a prosthesis more accurately. And that was the gist of that research. And they're still using it for some stuff, although the goal back then and still is to be completely neural, like a direct neural interface. But that's on an extremely case-by-case basis still and is not always possible. Other questions? Can I get, how old are all of you guys? Like, what, can we do a hands, like, how many of you are rising seniors in high school? Rising juniors? Rising sophomores? Okay, that's it, right? There's no rising freshmen?
Occasionally you wear
Okay. Okay, cool. I just want to get a sense. So when I already feel so removed from this process, when do you start doing college applications? Is it fall of your senior year? Okay. So you're starting to get ready for that this summer? Are there any questions about that or the college application process? Or more importantly, do any of you intend to apply to Cornell?
Do you have insider secrets?
Well, I mean, that depends. Are you intending to apply there?
Let's say yes.
This is, that question gets a lot better answers when I ask it in New York. There's not a whole lot of, I can't say I blame you. I feel like if I grew up in California, I wouldn't, I don't know. I think it's beautiful, but it's also, it snows a lot. Okay, my insider secrets are not specific to Cornell. It's to college in general, which is the number one thing that you can convey in an application is passion for what you want to work on. That will always trump a sob story or you finding yourself emotionally or whatever any of the other things are that people write about on their application essays. I don't know about for other types of schools, but definitely for engineering schools, and probably anything with a scientific background. Talking about how you're extremely passionate and basically want to become an expert on whatever topic it is, and what you've done so far to help you start to do that is huge. And so like the stuff that you're doing at Blue Stamp this summer, saying like, let's say you want to be a mechanical engineer, and you say, hey, I'm applying here because you have a great mechanical engineering program, and I desperately want to be a mechanical engineer. I've spent the last 3 years like building robots and teaching myself how to put things together, and showing that there's like a consistent passion for something. Not like admissions counselors can see straight through you if like you bullshit them. If you're like, oh, like I want to be a mechanical engineer, like, okay, what have you done to show that you want to be a mechanical engineer? Oh, I wrote about it on this essay. That's not meaningful. What's meaningful is to show that you've actually taken some initiative on your own to do something about it. So that's the best thing you can do. I've heard that repeatedly from friends who work in college admissions and stuff like that. And I can say like even for me, like interviewing people for jobs, I did a lot of interviews when I was at Google, and you can always tell like within a few seconds of someone walking in. It's not everything else can be taught as you go, but you can't replace like a passion for something. And so if you have that, you're golden. I think that's the most important thing. And then if you end up in any interviews where you get to do in-person stuff, I don't know if they ever do that, but definitely in the case of engineering stuff, bring props. Nothing impresses people more than bringing stuff. It doesn't even have to work. Like, if you have a tank robot that you're working on and it doesn't even work, you built it a year ago and you totally broke it, like bring it anyway. And I'm completely guilty of this from being on the other side of the table too. Like when people bring props to show what they work on and that they're proud of the things they worked on, it's like, you got me in the palm of your hand. It's the way to do it, for sure. Other questions? All good?
All right.
Cool.
Well, let afternoon students get to work. Morning students, you are